I titled my project Transparent Wood, A Window to the Future, because transparent wood has the possibility of being an alternative building material for the future and has the possibility of replacing glass used in windows. I chose this project because during the summer I read a CBC News article that said scientists had created transparent wood using a simple process that was so easy it could be done in a backyard. This piqued my interest because the idea of making transparent wood was really neat, and I also thought of how many different opportunities transparent wood could create. If transparent wood could be made in an environmentally friendly method, it could really bring a unique new building material to the construction industry and the design world. The purpose of my project was to determine if the method outlined in the article published by researchers at the University of Maryland was truly able to produce transparent wood. They used balsa wood in their study, so I wanted to take it a step further by using 3 different types of wood: balsa wood, white oak, and curly red oak, to see if there was any difference in transparency results. As well, I wanted to test each of the treated wood properties, looking at the transparency and durability of each wood, and compare them with each other. My first procedure was to create fully transparent wood. I brushed each wood with sodium hydroxide followed by hydrogen peroxide to oxidize the lignin in the wood structure. This was followed by 1 hour of UV exposure and would remove the chromophores that were embedded in the lignin. Chromophores give the wood its brown color. Then I soaked it in ethanol to clean out the chemicals, and then placed it in toluene to exchange out the ethanol. At the end, I brushed epoxy onto the wood pieces. For my second procedure, I tested the durability of the wood. So I placed 2 equally sized boxes and spread them around 10 centimeters apart. Then I placed one of the pieces on top of the boxes. I then placed different weights, a 20 gram, 100 grams, 200 grams, 500 grams, and 100 grams weight, onto the wood and recorded how far the wood bent and measured the lowest point of the wood to the ground. I tested this with untreated, treated it without epoxy, and treated with epoxy for red oak, white oak, and balsa wood. For my final procedure, I tested the transparency of each type of wood. I downloaded the Arduino Science Journal app, which is a program that can measure the illuminance of an area. I placed a flashlight between each piece of wood and shone it through the wood. Using the app on my phone, I set the baseline of the illuminance with a flashlight to ensure I started off with the same illuminance before I placed the wood piece in front of it. Once this was set, I placed the wood piece in between the flashlight and the phone and measured the illuminance. I repeated this step with untreated, treated, and treated with epoxy for red oak, white oak, and balsa wood. For my first experiment, none of the wood pieces were fully transparent after the procedure was completed. However, I was able to remove the chromophores because the wood turned white in color. I found that the wood with the greatest durability was the balsa wood, followed by red oak, and then white oak. The wood with the greatest difference in transparency was the red oak, followed by white oak and balsa wood. I think transparent wood is still a relatively new idea that still needs some work before it can be used in the real world. If they can manufacture transparent wood on a larger scale, the possibilities are endless. Some examples of where I think transparent wood can be useful is in the construction industry as a potential alternative to glass. It's also a more environmentally friendly material compared to glass. Transparent wood is also harder than regular wood, so you could make entire walls that are clear if you wanted to, and you wouldn't be limited by the properties of glass. It also opens up the building industry to new ideas for designs for buildings. Wood has better insulating properties than glass, and likely also stronger and less brittle, so there are many advantages over glass. Other industries that it could be used in is the automotive industry. It can be safer and stronger than glass, used for car windows. Another potential application is the furniture industry. There are many possibilities with transparent wood. If I were to choose a wood to use for future research or business that was interested in making transparent wood, then I would choose the balsa wood, as it was shown to have the strongest wood of the three woods I tested. The advantage of balsa wood is that a balsa wood grows 5 meters per year in a sunny environment. This tree is more sustainable. This tree is a more sustainable choice compared to the growth rate of the oak tree, which has a growth rate of 0.6 meters per year. The most difficult part of my project was obtaining the materials. I solved this problem by first asking any teachers and friends if they had any supplies. I was able to obtain ethanol and weights this way. Then I went across Mississauga, Oakville, and Burlington to find the wood and chemicals. The largest challenge was trying to find a vacuum chamber. These were not easy to find and very expensive. Because of this, I could only brush the epoxy onto the wood, which didn't mimic the procedure used in the researchers. The thing I enjoyed most about the project was doing the experiment. I was excited during the experiment to find out whether the wood turned transparent or not. When it turned different colors, I knew that the procedure was working. The other thing that I was excited about in this project was when I measured the transparency and actually found a difference in transparency between the types of wood. The other thing I was surprised about was during the stress test, I didn't expect to see the treated wood without epoxy to be stronger than the untreated one. This was very unexpected, but neat as well. This process did not fully create transparent wood, and I would further investigate reasons for why it did not get the same results as the University of Maryland researchers. I would reach out to them to review my results and identify any gaps in the procedure used. Curly red oak had the most difference in transparency, probably because it is the most porous wood. The challenge with white oak and red oak was that it dried wavy, so I would want to explore ways to make the final product flat and straight with this type of wood. If I could obtain a vacuum chamber, it would help me infiltrate the wood into the epoxy into the wood. Maybe this step could help me be successful in making transparent wood. And since a vacuum chamber is not that easy to find, I would try to see if I could find an alternative chemical that didn't require vacuum infiltration to make the wood transparent.